Okay, so we're going to talk now about something called the divergence and integral tests. These are ways to figure out if your series will converge or not. Because a lot of the times you have some what happens like a lot of the time is like in your physics or engineering problem, you're like, okay, cool, I have this infinite sum I need to calculate. That's like the force or whatever of what I'm interested in. And you're like, I'd really like to know if that goes to infinity, which means like the thing explodes, or like if it goes to some finite value, it doesn't explode. So you need some way to figure this out. A lot of the times the things you deal with will not be geometric series. If it's geometric, it's super straightforward. You just look at R and you're done. But what if what you're dealing with is not geometric? You're like, I don't know. So they invented this, basically. Cool, so we do that. We look at this. So, the first one is called the divergence test. So what does the divergence test say? The divergence test says that, let's say you have an infinite series, sum equal n equals 1 to infinity of an. So an is the sequence that you're adding up. The divergence test says that if the limit of the explicit formula of the sequence does not go to 0, then the series is divergent. So I'll explain what this means. So the explicit formula is this an. The series is obviously all of this. This is saying that if the limit of the explicit formula does not go to 0, it diverges. So let's say that you take the limit as n goes to infinity of your terms, and it does not go to 0. Then this thing diverges. Okay, it does not say that if it does go to 0, then it converges. Now this makes sense. If your terms are always bigger than 0, you're always going to be adding more and more and more of something, right? And if you're adding, like, let's say that your limit goes to 1. So example, let's say that the limit as n goes to infinity of an equals 1. That means your terms are getting closer and closer to 1. That means at some point, it's like you're adding 1 for each new term. If you keep on adding 1 for and ever, that adds up to infinity, right? So it diverges. So this is a quick way to show, like, oh, this diverges, like, it blows up. But usually you want to show that it converges. So it is inconclusive if the limit goes to 0. You don't get any valuable information if the limit equals 0. It could converge or diverge. So that's an important thing to realize here. Like, if the limit goes to 0, it tells you nothing. It could converge or diverge. What you do know is that if it's not equal to 0, then it definitely diverges. So let's use this as an example. Or if the limit doesn't exist. I guess I should say that. If the limit is not equal to 0 or does not exist, then it diverges. Okay, so some examples. One. Let's say your sum equals n equals 1 to infinity of n over 3 minus 1. So you're like, okay, cool. Divergence test says I should take the limit of this thing. Okay, because this is an infinite limit and it's a rational function and the power on top is 1 and the power on bottom is 1, you could just take the ratio of their coefficients, right? So you get 1/3. You're like, oh, the limit is not 0, so the series diverges. Because you're basically adding, all those terms are getting closer and closer to 1/3. So it's basically like you're adding 1/3 forever. You keep on adding 1/3 forever, it explodes to infinity. The series diverges.